Hello, everybody. Thank you for your attention to my presentation today. My term project is about the application of decision tree, artificial neural network, and random forest algorithms to predict undesirable events in the oil wells. You know that in an oil wells, many problems is associated with a petroleum production system. And the figure right here you can see is an accident happened in Gulf Coast of Mexico in 2010. This is the drilling rig named Deepwater Horizon, and the reason of the accident is because of there is no good approach to monitor the risk of drilling. You can see that the consequence is very serious, and it caused many economical costs as well as human casualties. So in modern days, many companies they try to find a method that can help prevent the unexpected events in oil and gas field. And one of the methods that they use is employing machine learning models. And there is actually a company in Brazil. They collect the data in the fields, and those data is associated with a certain types of problem in the wells, and they use the data set to train the machine learning models and predict the abnormalize in the anomalies in the wells. So you can see that in the table on the left side, you can see a table. It is a summary of the instances or the wells that the companies has collected, and you may notice that beside the real instance, there are simulated instances and also the hand drawn instances, and the total number of the wells is 1,984 wells. And together, this dataset is called the 3W dataset. And this dataset is used by many researchers to build machine learning models for anomaly detection. Let me give some more description about the 3W dataset. The 3W dataset, besides the normal and abnormal labels, there is a transient state. It lies between the normal state and the abnormal state. So it is called the transient, happen right before the steady state or abnormal state. And so we have totally 8 problems. So in this table, there are 8 problems associated with an oil wells. And with the transient state, you can expect to have another 8 transient state. So totally we have 16, and we plus the normal state, so we have 17 classes in total. But in the dataset, there are actually only 15 classes, and I listed here. The dataset does not contain 103 and 104. So totally 15 classes. In order to apply successfully the algorithms on the 3W dataset, we try to summarize the 3W dataset so that we can see what contains in the dataset. And when we summary, you can see that the table here, the table 2, is the summary of the 3W dataset, and you can see that the last 3 features, they have too many missing data. So we decided to remove those the last 3 descriptive features, because you can see that there is totally more than 50 million instances. However, these last 3 filters contain too many missing data, and if we try to conduct some data imputation, it will not be effective for the predictive models. So in order to achieve a high accuracy on prediction, we remove the last 3 descriptive features. We only keep the first 5 features. And you can also notice that there are some missing points and a values in the first five features also. But it's not a big problem because the number of missing data in these features is relatively small compared to the whole data set. So we decided to keep these five parameters to use as descriptive features for machine learning models. And also for data imputation, we use mean value to fill in the NA values. And this is the result before and after we apply data pre-processing technique. So you can see that the p.pdg is the first features and so on, so on. So you can see that the distribution become more consistent, and we can use to build the predictive models based on after data processing. And after apply the machine learning algorithms on the data set, we achieved some results, and the results are summarized in a confusion matrix. So because this is a multi-class classification problems, so the confusion matrix should be calculated for each of the features of for each of the class. And you let me remind that we have 15 classes. So for each of the 15 classes, we calculate the true positive, true negative, false positive, and false negative for each of the classes. And this is an example of the confusion matrix for multi-class classification problems. So for simplification, we don't show all the confusion matrix here, but in the appendix you can find the confusion matrices. In this presentation we only focus on the accuracy of the training and testing for each algorithm.
One of the algorithms that was implemented on this dataset was the decision tree algorithm. So from this, based on which feature would give the most data or the most information gain to the prediction, a feature was chosen in order to be able to separate the data down to a point where it would be able to ultimately predict the final classification. We pruned the tree, and after the pruning, our results are shown here. The accuracy is pretty good across the board. We get between 75, we generally get between 75 and 95 in both precision and recall for any given class. Overall, the accuracy is about 78%, which is an improvement of the original 70% accuracy before the data cleaning and tree pruning. However, some classes, such as Class 4 and Class 1, have lower recalls than precision because for those classes, the decision tree model alone has a high false negative rate. Finally, we implemented an artificial neural network as an attempt to classify the data because this is a method that is good at capturing nonlinear patterns of the datasets. We used 2 hidden layers for our neural network with 15 hidden nodes and 10 hidden nodes respectively. And then finally from there using softmax for the output nodes to classify the highest predicted class. The dataset was very large, and because of this, it ended up it ended up becoming a large time and computer hardware limitation for us. And as a result, this simple A neural network model was the only one that we were able to run within a reasonable amount of time. So we focused on pre-processing the dataset to improve the accuracy instead of changing the ANN architecture. As for the results are quite good. Generally, they are at least 90%, all the way up to almost 100% in both precision and recall, resulting in high F1 scores. The overall training and testing accuracy is 98.8%. It does not perform as well as the bagging random forest, but these results are still very good, and if anything, indicate a more generalized model to be implemented. But the runtime is much longer than the random forest model, and as such, that one outperforms the neural network. One thing to note with the A neural network model is that the class 7 has low precision and not as good recall as any of the other classes. And this is because class 7 does not have as many data points as the other classes. Vargas et al. Stated in the original dataset that class 7 is underrepresented and not reliable to be used for predictive models. And these results do corroborate that information, that predicting class 7 is a difficult task using this dataset.
The last algorithm that we apply on the 3W dataset is the random forest using bugging technique in order to improve the accuracy of the models. So the random forest we built contain 15 decision trees, and the final results are achieved by voting among the tile trees. So you can see this is the schematics of the random forest models. So we are each of the tree in the random forest contribute to the final vote, and the final vote is the final prediction that we use for each instance. And this is the results of the random forest algorithm that we apply on the dataset. And you can see that overall the accuracy is extremely high, nearly 100%. And the metrics of precision, recall, and F1 scores are also really high, nearly 1. So this result show the power of back-in random forest algorithms on this dataset. And in order to wrap things up, we would like to compare the three algorithms in terms of precision, recall, and F1 scores. So you can see in the first graph, we compare the precision of the three algorithms, and the random forest and artificial neural network performs very well compared to the decision tree. So for the decision tree, its precision is lower than the other two, and also in the same pattern can be seen in the recall, and also the F1 scores. So in the three metrics, the random forest is the best method with highest accuracy. Next is the artificial neural network, and the least performance belong to decision tree. And we can also notice that especially for class 7, the artificial neural network performs not very well. This is can be due to the underrepresentation of class number 7 is mentioned by the other authors who also focus on this data set. So one of the authors is Vargas. He stated that class 7 is underrepresented and it should not be used for building predictive models. So my suggest our recommendation is for further research. If people want to do research on this topic, they should remove the class 7 from the data set so that the predictive model is more reliable. So in conclusion, among the three algorithms, random forest with backing technique is the best method that we can apply on this 3W dataset. And although the decision tree and artificial neural network they perform lower than the random forest, we can further improve these methods by tuning the hyperparameters. But I think the best method to improve these algorithms' performance is to validate the quality of the dataset and collect more data instances so that the dataset is more complete and more reliable for predictive models. And also, in order to improve the accuracy, we suggest that class 7 should be removed from the dataset. And also, in this papers, in this project, we used mean value for data imputation, which means that we use the mean value of a features and we fill in the NA value of that features. But other methods can be used for data imputation, and maybe and hopefully they can be more effective than our method. Also, for the confusion matrix, you can find in the appendix of my report or even my presentation I showed here. And this confusion matrix are used to calculate the precision, the recall, and F1 score as I showed in the previous slides. Now, these are the references that I used during my project. And thank you very much for your attention and your interest in my presentation and topic.